Welcome to this presentation introducing the RCPA QAP Key Incident Monitoring and Management Systems, or KIMMS as it is commonly known. KIMMS collects data about key incidents that are known to occur when processing and reporting pathology results. Once an incident or error occurs, it has to be identified by staff who are usually further along the processing chain. For example, specimen reception staff recognise collection incidents. The incident is then recorded in the LIS. The best way to do this is for the staff member who recognises the incident to add a result code to the patient record in the LIS that identifies the category of the incident. The answer to this code identifies the type of incident and is usually another code but could be a comment. The number of results are then extracted from the LIS once every 3 months and reported to KIMMS, who in turn return a report to the participant showing their data, called YOUR, and the total data submitted by all participants, called ALL. Participants in the program may be a combination of several laboratories from the same organisation, a single laboratory representing a larger organisation, or a standalone laboratory. The KIMMS incidents were chosen as those that represent the most common or highest risk incidents that occurred during the collection and processing of pathology samples or specimens. The KIMMS incidents are grouped together into categories based on when the incident occurred. 4 are pre-analytical and 1 is post-analytical. There are 2 other phases that are talked about in the literature, where the doctor decides which tests they need and completes the pathology request form, and the post-analytical phase, where the doctor interprets the report and decides on the correct treatment. These are not covered by this KIMMS program, but can be the subject of the KIMMS audits, which look more deeply into events on a one-off basis. Pre-analytical phase identification incidents. All patients are positively identified before the collection commences. Correct and complete patient information is recorded on the sample and request form, and where possible, the patient checks the details. This category has 4 indicators. Note also the recording of your count and all count. Samples with ID errors should be rejected. However, for a variety of reasons, some are not. These would be situations where the risk of not performing the test is seen to outweigh the risk of the sample being given to the wrong patient. KIMMS deals with this through an incident category called Other Samples Accepted. Laboratories report the number of samples with identification errors that have been rejected, and the KIMMS program subtracts this from the total number of ID incidents and reports it as Other Samples Accepted. In the case above, the total identification incidents is 300, none of which were rejected, so 300 were accepted. A separate category was introduced for transfusion samples, as any pre-analytical error with these samples must be rejected. A transfusion incident that is not rejected, that is accepted, becomes the second incident within this transfusion category. It should be, and almost always is, 0. Once the sample is collected, it is stored and then transported to the laboratory. This is called the pre-analytical phase, collection and transport incidents. There are 6 indicators in this area. The final pre-analytical phase category is called laboratory incident. These are incidents that occur within the laboratory, such as tubes breaking in a centrifuge, pipetting the wrong patient into a numbered tube from a work list, and any data entry errors that are not fixed before the report is issued. There are 3 incidents in this category. Once the analytical work is completed, the post-analytical phase begins. Post-analytical incidents have 2 indicators. Turnaround time failure is an overall indicator of quality rather than a pre- or post-analytical error. Any breakdown in pre-analytical phases could cause an increase in turnaround time. Turnaround time failure is designed so that each laboratory measures themselves against their own specified turnaround time, as this can be very different in different situations. The turnaround time measured is from the receipt of a sample into the testing laboratory until availability of results. A different analyte is chosen each 6 months, that is 2 surveys for each analyte. Laboratories can choose to report on urgent or routine samples, or a mixture of both. Other statistics measure how effectively incidents are detected by the laboratory. Are they picked up by the laboratory's own quality system, or are they a result of complaints? In this example, 1,322, or 9%, were by complaint and 4.6% by quality system. The vast majority, 11,599, are unknown. Whether this is unknown to the laboratory or just not reported to KIMMS is unclear. What is the root source of the incidents? Was the issue caused by your own staff or external staff? In this case, 35% were caused by outsiders and 44% by own staff, with 20% unknown. Unfortunately, the majority of participants are unable to collect this data on all of their incidents. 63% of how the incident was detected and 50% of the root cause are unknown. The peer review page is the best way to view how you were travelling compared to your peers. However, it can only be used as a guide. Results are all expressed as per 100 or 1000 episodes. Your data is the dark grey point. No dark point means no values entered by this laboratory for this indicator. Notice that insufficient identification incident has less variation in values than any within laboratory failure of ID. This is most likely due to the fact that insufficient identification is much easier to define, identify and report than any within laboratory failure of ID, which is interpreted different by different participants. Points that should be investigated are the single outliers. Here you can see that there is more than one participant with elevated results compared to others. This could be due to how well the data is collected, rather than more events occurring. Example, laboratories with coagulation instruments that flag underfilled samples. The cumulative data page supplies a summary of results for each category for the past 4 cycles. Any major changes in the percentages from survey to survey in your data should be investigated, firstly by referring back to the individual incidents within a category. The risk per episode results for your data show an overall comparison by quarters for your results and for the whole of KIMMS participants through the all data. All participant summary shows the percentage of incidents per episode, which incident has the highest frequency and which is the highest risk in each category. The overall contribution the category makes to the total risk is also given. In conclusion, the KIMMS program came into being in the very early days of acknowledgement that pre- and post-analytical errors in pathology pose some of the biggest risks to patient safety. It introduced the concept of risk rather than simple frequency at a time when it was a very novel approach. The KIMMS Advisory Committee is working to update the report to better match the expectations of risk and risk management in today's world. However, KIMMS is only useful if the data can be collected by the laboratories effectively and sustainably. We urge all laboratories who are not currently monitoring this data to start sooner rather than later, and for anyone contemplating a new LIS to ensure it can supply this information. Thank you.